Okay, so this topic is called superposition. It's where we now interact two different types of waves. This is a optical illusion. Just stare at it for a second. So the principle of superposition is when two waves meet, the resultant displacement is equal to the vector sum of the individual displacements. In other words, we're talking about the rise up and down of the waves. If we're looking at a transverse wave, when you have two waves meeting, we'll add the two rises to get a new one. The two waves must always be the same type. Okay, in other words, there must be either water waves or sound waves or light waves. Interference is the result of superposition, so an interference pattern can be created due to superposition. If the wave is the same, the polarization plane must be the same as well. Okay, so there must, if the transverse waves, which polarization only happens with transverse waves, it must be up and down. It can occur with both transverse or longitudinal waves. That's superposition. Okay, it can occur with both of them. So if we have these two waves here, we have a green wave at the top there, and we have the red wave there. Then if we add the displacements of each point, so we look at the displacement there of this one, the red one, and the displacement there of the green one, if we add the two heights, okay, so the height to there for the red one, and the height to there for the green one, we then get this blue height here, okay, at that point. So once you do that at certain points along the line there, you can then get a new wave, which is found here, that blue one. So two types of interference or superposition. You can get constructive interference. These waves are in phase. They're vibrating in the same time. So when you add these together, crest and a crest will make a larger crest. Okay, so we call that constructive interference. This one down here, destructive interference. The crest here, essentially, if we draw a graph line across there, and on this one, this side here, oops, the height there plus the negative height there, so that's a negative, this one's like positive. If we add that plus that, well, they actually cancel out. So that's destructive interference. So here's an example you can do this quite quickly. Essentially what we're going to do is start off with a couple of points. So this height here for the blue wave is at 1, 2, 3. So 3 plus 1.5, 1.5. Okay, that gives us 4.5. So let's go up 4.5. Let's change my color to green. So go up 4.5. 1, 2, 3, 4.5. That's where the new wave is going to be. Okay, we won't actually see these two waves if they were like water waves. If we're looking at the surface of water, we would actually see just one wave, and it would be the resultant wave from the superposition. So next point here is 2 and 4. So 4 and 2 makes 6. So that's up here. Okay, and then we carry on. So you can try that.